Let's shift our focus to deployment. Moving from cloud validation to full operation, and wrapping up with a look at our internal developer platform. A capability that lets us do more deployment with less. We rehearse using a cloud cluster. Importantly, this cluster is disconnected from the cloud catalogs and configured to only source images from the local registry, effectively simulating our air-gapped network. This upstream phase isn't just about validating the registry contents. It's where we identify, evaluate, and mitigate security vulnerabilities early in the lifecycle. In addition, we also install and configure our core operators. This process enables us to refine and prove our procedures. For this cluster to serve as a suitable disconnected upstream, the deployment must be self-managed OpenShift. While the managed offerings are convenient, they unfortunately hide the management nodes and critical machine configurations. With a self-managed cluster, we have full access to the control plane nodes, and the freedom to tune all OpenShift configurations. We can even schedule upgrades on our own timeline. This combination of self-managed control and disconnected validation gave us the confidence for our air-gapped deployment. With the upstream validation complete, all that remained was the pre-deployment readiness check. The mirror registry is fully loaded and validated. Our network design is locked in and double-checked. We have acquired the enterprise CAs and our signed certificates for all services. Lastly, a final hardware check to verify that each component is ready for deployment. With the right preparation and planning, the actual deployment will be smooth. We've already done all the hard work. Once the cluster is running, the next priority is configuring the core services that keep it healthy and resilient for the long term. Monitoring is the first line of defense for both the platform and the applications you deploy. OpenShift includes a built-in monitoring stack that tracks services and issues alerts. By default, it focuses on cluster health only. The application workloads are not tracked. So, we configured user workload monitoring, which enables Prometheus and Alert Manager to track the full cluster. We also created cluster-wide custom alert rules, such as tracking out-of-memory pod kills. This allowed us to surface these silent issues and enable the ops team to address the cause. A key part of our setup is alert routing. Alerts are only present while firing, so recording them is essential. We configured an Alert Manager receiver to send email notifications. This captures brief or transient events that may go unnoticed. The next key layer is centralized logging. We deployed and configured Vector to collect logs from every pod. Vector then forwards those logs to Loki. This operator persists the logs off-cluster in S3 buckets on our storage array. This ensures that in the event of a cluster failure, our complete log history remains secure and accessible for audits and investigations. When we needed in-depth monitoring, we deployed the Cluster Observability Operator. It provides custom monitoring stacks scoped to specific namespaces. This enables teams to optimize or troubleshoot key capabilities. And finally, for quality of life, we utilize Keycloak for single sign-on, one login for all cluster applications. With the core services in place, the platform is ready for the real goal: empowering application teams. This is where our internal developer platform, or IDP, takes center stage. At its foundation is our registry server, which supplies the packages, Git repositories, and container images. Everything a developer needs to build and release software inside an air-gapped environment. Above that foundation, 4 operators power the workflow: OpenShift dev spaces, pipelines, GitOps, and advanced cluster security. By leveraging built-in automation, we enable small teams to do more with fewer resources, accelerating delivery while reducing manual effort. The platform is secure by design. Starting with the foundation, all our custom container workloads are built on universal base images. These images are hardened by Red Hat and benefit from regular vulnerability patches and security advisories. Next is quality. Our pipelines are more than just automation. They enforce unit tests, code coverage, and coding standards, ensuring every commit meets a baseline of reliability and maintainability. Red Hat Advanced Cluster Security delivers the next two pillars: scan and detect. An ACS scan has been integrated into the promotion pipeline for new images. This task identifies known vulnerabilities and flags insecure configurations, such as running containers as the root user. If critical issues are found, promotion is blocked and developers are notified. This proactive approach ensures that insecure images never reach the cluster. At runtime, ACS continuously monitors the cluster for anomalous processes, suspicious network activity, and privilege escalations. It doesn't just detect, it enforces. By blocking policy violations in real time, ACS ensures the cluster remains secure. Again, security is not just a single layer. It's a discipline that is enforced at every stage. Our developers love OpenShift dev spaces because it provides a cloud-native development environment with everything they need on demand. With just a browser, developers can start coding in minutes in identical, reproducible environments with no local setup required. Using a dev file, each workspace is defined as code, specifying all containers and resources needed to build and test an application. This approach accelerates onboarding and eliminates the classic, "But it worked on my machine." By ensuring every workspace runs from approved images and with consistent configurations. As developers finish features, they commit to the quality assurance branch. That action triggers the validation streams within the Tecton pipeline. Parallel execution means a shorter feedback loop, giving developers the insights they need without relying on specialists. Once validated, the image manifest is committed to the configuration repository. This triggers Argo CD to roll out the new image to the cluster, allowing the team to complete system integration and user acceptance testing. The result is a promotion process that is consistent, reliable, and trusted. With it, we can release to production with confidence. That was a very brief look at our IDP. Now, here's why it matters. It delivers security. Every image is built on a secure foundation, and our registry only contains verified, trusted artifacts. It delivers speed. A developer can be productive in minutes, not days. One-click environments means lower onboarding costs, faster delivery, and more time spent building capability. It also delivers continuous assurance. Automated pipelines enforce testing, building, and scanning. So by the time we're ready to release, the software is already proven. And finally, it delivers confidence. Because the cluster is managed by GitOps, every deployment is consistent, automatic, and free from human error.